The calculator portion of the final exam will have all of your right triangle and law of cosines and law of sines triangles. I'm not going to review those because we just finished that up, but think of all of your angle of elevation problems and angle of depression problems. Think of all of your law of sines and law of cosines problems. Think of all of your solve the triangle problems where you have to find all the missing sides and angles. So because you need a calculator to do those things, they'll all be on the calculator portion of your test. In addition to that, you'll have the area of a triangle formula on the calculator portion of the test. And so, but what's the stuff from so long ago I can't remember on the calculator portion? The stuff from so long ago that you can't remember is the harder probability questions and expansion and linear and angular velocity. So let's start off with reviewing probability. So you need to know in an NPR and an NCR problem and in a basic multiplication problem, when to use them, how to do them on your calculator. That says multiply because I couldn't write multiplication all the way. So you don't necessarily need to know the formulas for the calculator portion of the test. You need to know that this is a problem that's like a race where the order matters. And this is a problem like a drawing where all 5 people get the same prize. So the order does not matter. And you need to know that NCR is sometimes written like this, 10 choose 3. And actually, I'm going to assume that you did the review packet and you have the formulas written down somewhere. So in the calculator portion, you should probably just make sure you know how to access the Math PRB menu and type them in. And then when to use the basic multiplication rule, like the license plate problem. We'll end the year with bad spelling, just like we started it, like the license plate problem or the kittens problem or a cards problem or a Venn diagram or a chart problem. So here are some examples. Let's say I wanted you to rearrange the letters in the word study. Like, how many different ways could I rearrange these letters? This would be basic multiplication. There's 5 possibilities for the first letter, 4 for the second, 3 for the third, 2 for the fourth, 1 for the last. So that's a basic multiplication probability problem. Now, your textbooks always talk about marbles or socks, but I like to talk about kittens, because couldn't you have a bag of kittens just like a bag of marbles or socks? So let's say I had 2 males and I had 3 female kittens, and I wanted to know the probability of drawing 2 males. So there's 5 kittens, and there's 2 males in that bag of kittens. There's my kitten bag. And the thing is like once you take out a kitten, you can't help but hold it, and so you're not going to replace it and put it back. You're going to keep that one kitten and then draw another male. There's only 1 male left, and there's 4 kittens left. So in this bag of kittens, we have 2 out of 20, or a 10% chance of getting 2 males. So, bag of kittens, bag of marbles, bin of socks, those are all the same type of conditional probability questions that you have to use the basic multiplication rule, but you have to think about how the probability changes each time. Then you have problems involving permutations and combinations. Let's say I had a $500 prize for first place and a $200 prize for second place and a $50 prize for third place. And I had 10 students, and they all had to take some sort of a fancy exam, and we actually had cash prizes for good grades on math tests. How cool would that be? Anyway, this is going to be 10p3. It's a permutation. How many different possibilities are there for first, second, and third place among the 10 students? But let's say instead of that, I just happen to have, let's say, a gift certificate for $20 to Joel's. And I was going to draw 3 students. Now, in this case, it wouldn't matter which students got the $20 gift certificates, so the gift certificates are all the same. So if I want to know how many different ways that can happen, this is going to be for my 10 students. So I've got 10 students, 3 of them get the fancy gift certificate for Joel's. This is going to be 10 choose 3, which can also be written as 10, 3 like this. The reason I keep talking about how it ties into this number is because you have to know the relationship between combinations and the binomial expansion. So let me do a simple problem. Let me not that simple, but anyway, let's say we had to expand a minus 3m to the 5th. So you're going to have to write out x to the 5th plus x to the 4th y plus x cubed y squared plus x squared y cubed plus x y to the 4th plus y to the 5th. And then if you're a Pascal's triangle person, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. This is the 0, so let's count with a 0 row, first row, power 2 row, power 3 row, power 4 row. Oops, I've got one more row to go. It's going to be the 1, 5, 10, 10, 5, 1 row. And so 1, 5, 10, 10, 5, 1 row. And now, if I want to find, let's say, find the x cubed y squared coefficient, I would need to, let's see, that's this coefficient, and it's going to be 10 times a to the 3rd times negative 3m squared, and my coefficient is going to be 90. A cubed m squared. And I get this number right here either by using Pascal's triangle, or you should know, and I don't know how to fit this all in on one piece of paper, but this is 5 choose 0, and this is 5 choose 1, and this is 5 choose 2. So I could have gotten that coefficient of 10 by using combinations instead of Pascal's triangle. The calculator portion of the test also has linear and angular velocity, and the thing you really need to know, the key to these problems, is that 1 revolution is equal to 2 times pi times radius. So if I wanted to convert a bicycle tire that had a 24-inch diameter into, let's say I'm going 10 miles per hour, and I wanted to convert it to revolutions per minute. Well, the hours to minutes would be pretty easy. I would know that there's 60 minutes in 1 hour. But the other part's a little bit harder. I need to know that there's 1 mile is 5,280 feet. And now that I've got feet, I need to go to this conversion right here about revolutions. So this has a radius of 1 foot. So 2 times pi times 1 feet is 1 revolution. And when I get out my calculator, I type that as 10 times 60 times 5,280 divided by 2 times pi times 1 to get the answer. So what about the no calculator portion? The no calculator portion of the test is mostly trig because we've been doing mostly trig for the entire semester. And it's got lots of exact value problems, lots of sines and cosines and tangents. It kind of goes back and forth between degrees and radians. And so I would say, like, if I had to pick key things that people tended to have trouble with, most students don't have a problem. Like, if they know the sine of theta is 1/2, and it says find the cosine of theta, well, you know that theta would be 30 degrees here, and so the cosine of 30 degrees is the square root of 3 over 2. So in general, I think you guys don't have a problem with exact values because we had to use them so much. But I have had students have a lot of trouble with this type of problem, even my good students. Sine theta is equal to, let's say, 3/5, and the secant of theta is less than 1, and find the tangent of theta. Because this is asking a lot of extra information, and the extra information it's asking you is kind of a, well, not a doozy, but like you have to look here and think, well, the sine is positive and the cosine is negative, and so if the sine's positive and the cosine's negative, that's over here in this quadrant. And if the sine is 3/5, then I'm going to have to get out and do Pythagorean's theorem, a squared plus b squared equals c squared, and go 3 squared plus b squared equals 5 squared. The numbers probably won't be that easy on the test. And after you get that this is 4, you have to put in -4. You have to associate the sign with the right quadrant, and then answer the question, tangent of theta is equal to 3 over -4, because that's the opposite over the adjacent. So it should be that you know your exact values, but you might get hung up when you have to do a problem that involves using the quadratic equation because it's not an exact value. Now, I don't have very many people that have forgotten the basics, but just in case you are having trouble with radians and degrees, that's the conversion. So if you had a problem that said 5 pi over 6, oh, let's not do 6. Let's like a 5 pi over 12, something you don't know. And we needed to convert this into degrees, I would look to myself and think, oh, the pi is on the top, so I need to put a pi on the bottom to cancel. And then I would go 5 times 180 divided by 12. So that's 5 times. Yeah, I just shut the computer off and got out my calculator for a second. That's 75 degrees. So, if you've had trouble with trig, make sure that you know how to convert radians to degrees. One thing we haven't reviewed in a long time is how to graph a sine, cosine, and tangent function. And so I'm going to write a sine of bx plus c plus d. And one little detail you need to know is that sine and cosine have a normal period of 2 pi. And for tangent, the period is pi. And if it's not the basic function, and for sine and cosine, the period is going to be 2 pi divided by b, and for tangent, it's going to be pi divided by b. So you're looking at this number right here to decide what the period is. Now, when you look at a, this number right here, the a is going to tell you the amplitude, but it's also going to tell you whether or not to flip the graph over. So y equals sine of x would look like this. But if you had negative sine of x, it would look like this. And this portion of it right here, you need to take bx plus c, set it equal to 0, and solve it. That will give you your horizontal shift. And this number right here is your vertical shift. And a is also your amplitude as well as the flipping upside down thing. Most people who struggled with amplitude and period had a really hard time distinguishing the difference between these two problems. In this case, the b value is equal to 2. And so the period is equal to 2 pi divided by 2, which is pi. So you should know that your cosine function normally looks like this and goes back up in 2 pi. So if you changed your period to pi, it would do its down and back up and stop right there. Now in this case, the reason students had trouble is because they're not seeing this as the cosine of 1/2 x. And so now in this case, the period is 2 pi divided by 1/2, and then we have the people who just can't divide fractions. That's equal to 4 pi, and so in this case, the cosine function gets stretched out. I just stretched off the graph, Let's try that again. The cosine function is going to get stretched out into where this number is at 4 pi. Okay, I'm not going to go over identities. I'm not going to go over exact values of sum and difference identities or solving trig functions, because there's like maybe 6 questions just like straight off the chapter 5 test. You just had that test. It should be pretty fresh. If you want to review that, you should review that on your own. I am going to write down these formulas for you. NPR is equal to n factorial divided by n minus r factorial. NCR is equal to n factorial over r factorial times n minus r factorial. You will have a non-calculator portion of the test where you might have to answer something like 6 choose 2. Now you could use Pascal's triangle for that, but you could also go 6 factorial over 2 factorial times 4 factorial, which is 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 4 times 3 times 2 times 1. Cancel, cancel, cancel. 30 divided by 2 is 15. And the last thing you'll have to know for your final is explicit and recursive rules for addition and multiplication problems. So let me write the formulas for both. A sub n plus 1 equals A sub n plus d. That's your recursive formula for an arithmetic sequence, which is like an adding or subtracting sequence. And here's your recursive formula for a multiplying or a geometric sequence. A sub n plus 1 equals A sub n times r. Okay, here are the explicit formulas. A sub n is equal to A sub 1, the first term, plus the common difference times n minus 1. And here it's A sub n equals A sub 1 times the common ratio to the n minus 1 power. And you have to be able to identify the formula. So if you had a problem, for example, that had -1, 4, 9, 14, 19, you would have to look at that and decide, is this an adding rule or is this a multiplying rule? Okay, if this is an adding rule, I'm adding 5 each time. If it asks you to write the recursive formula for this problem, it would be the next term is equal to the first term, or sorry, just messed that one up. The next term is equal to the previous term plus 5. That's the recursive formula. If you had to write the explicit formula, it would be the nth term is equal to the first term plus 5, that's a common difference, times n minus 1. Now, this is a multiple choice test, so you could just plug the numbers into the formula and see if they come out with the right answer. And last but not least, you'll need to know how to read sigma notation. So like if it said to find the sum from n equals 1 to 4 of 2 to the x power, and what's that equal to? Or it might say right out the sequence, you're going to know that 2 to the first power is 2, and 2 squared is 4, and 2 cubed is 8, and 2 to the fourth is 16, and that this notation means to find the sum. And so this would be the series 2 plus 4 plus 8 plus 16, and if it asked to find the sum, the answer would be 32, if I had it right. And I didn't add right. It would be 30. So sigma notation, either know how to find the sum or how to generate the series.